Okay, I want to work a few of these simplifying radical problems, and hopefully some of the ideas I discuss here will clear your mind of any ambiguities. This first problem is a cube root, and that means that within the radical, under the radical, within the radicand, we're going to be looking for triplets or cubes. Now I'm hoping that you're familiar enough with powers of 2 to realize that I can rewrite 8 as 2 cubed. And the x already comes packaged as a perfect cube, which is nice. The y, however, is only to the second power, and there's nothing really we can do or want to do to upgrade it to a third power. We simply copy it as it is. Now, I'm going to write this problem out, my next step, in a little more detail than I expect you to do, and I'm doing that to illustrate a principle. I'm going to go from a house united to a house divided like this, times the cube root of x cubed times the cube root of y squared. Well, I think you can see why I call this a house divided. And now the principle that I wish to demonstrate is that the cube root undoes all cubes. They are literally inverses of each other, and they annihilate each other. So it's sort of like a canceling problem. The cube root undoes the cube, and we're left with simply 2. Similarly over here, we have this cube root undoing this cube, and we're left with x. Now over here there's nothing more to be done. There's no cubes or triplets in here, so all we can really do is copy this. And essentially that is our answer right there. That is the simplification of this problem. There's only one other thing you might have done, and depending on the context, you will be asked to do this sometimes, is rewrite the part that you can't simplify it all, rewrite it as a fractional exponent. And in this case, it would be y to the 2/3. Either one of these answers is perfectly legit. I think this is the one they were going for in this part of the book. Now I want to show you another problem, and let me move this aside. And here is a discussion post. I want to work problem 3 here because it has an interesting twist that I notice a lot of you make on your homework. It's a potential fatal error. Essentially, my way of doing these problems is, since we have an index of 3 here and an index of 3 here, I can go to a house united. And most of you will do that too. But the thing is that I won't do the multiplication. I'll show it, but I won't do it. You guys will multiply out 25 times 5 to get 125, and then you'll have to break it apart again into its atoms. The best way here to avoid the potential of errors creeping in is simply to rewrite everything as atoms. In other words, I'm going to rewrite the 25 as 5 times 5. And now I'm going to show this factor of 5. And now let's do the exponents. We have x to the 4th times x, which is x to the 5th. But because this is a third root, we're looking for cubes. I'm going to write x to the 5th as x to the 3rd times x squared. Remember, when you're multiplying and bases are the same, you add the exponents. So this is really x to the 5th. With the y's, I've got y squared times y to the 12th, which I could write as y to the 14th, or alternatively, I could write it like this. There's 6 of them, there's 9 of them, there's 12 of them, there's 14 of them. Now remember, the cube root undoes all cubes. Here is 1 cube, and so we're left with 5 on the outside. Here is another cube, an x. Here are 4 y cubes, 4 of them. And what didn't get touched by the cube rooting? This and this. They got left behind. And so I leave them behind underneath the cube root. There's my answer right there. Now, I just want to take a second here. Let me clear this out of the way. And since exponents are a trouble spot for a lot of people, let's just do a quick review. There's a case where you add exponents. When you're multiplying the bases the same, you add them, x to the fifth. There's a case where you subtract exponents. When you're dividing the bases the same, you subtract them. 3 minus 2 is 1. So we have addition, we have subtraction, and then there's a case where you multiply them. When you have powers to powers, you would multiply these to get x to the sixth. Now the question is, you've dealt with those three. What is there a case when you actually divide exponents? And yes, there is. In fact, this is it right here. To come full circle in the course, think of this like this. Let's go to a house united. And let's go ahead and say that this is 2 5s times 1 5, or 5 to the third. I've got x to the fourth times x, or x to the fifth. I've got y to the second times y to the 12th. We're adding here for y to the 14th. So another way to do this is to think of this as division. 3 goes into 3 one time with no remainder. 3 goes into 5 one time with a remainder of 2. 3 goes into 14 4 times with a remainder of 2. And that is in fact the same answer I got on the previous page. 5 times x times y to the fourth times what got left behind. 5 times x times y to the fourth times what got left behind. So, full circle in the course. There's 4 cases where you add, subtract, multiply, and divide exponents. Well, I hope that helped, and I hope you found it somewhat interesting. And good luck with the rest of Chapter 7.